What is a limiting reagent and how can we find the limiting reagent in a chemical reaction? Why this limiting reagent is important? All these things we are gonna learn in this particular lecture. So dear students, in a chemical reaction, when you look at the reactants in a balanced chemical equation, the balanced chemical equation tells us basically the reaction, the ratio of the reactants in which they combine and they form the product. Let's suppose here in this particular reaction we have the reactant A which reacts with the reactant B and forms the product C. And the ratio in which the reactants combine over here is 1:2, right? So 1:2 is the ratio of the reactants. Now, when we do the reaction and practically in the lab, if you take the reactants in a different ratio rather than this 1:2 ratio, then you will see definitely one of the reactant will get exhausted first, and then the other reactant will remain there at the end of a reaction unreacted. The reactant which is getting consumed, which is getting exhausted first in the reaction, is called as our limiting reagent. Now the question here is, how can we identify the limiting reagent and why this limiting reagent is very important in the reaction? Now to understand this limiting reagent clearly, let's take here an example. In this example, let's suppose a very good recipe of making 8 cookies. Okay, so you know how to prepare, let's suppose 8 cookies. All right, you know how to prepare the 8 cookies from the eggs and the flour, right? To prepare the 8 cookies, let's suppose that you need 4 eggs, right, and 3 cups of the flour. So to prepare 8 number of cookies, you need 4 number of eggs and 3 cups of the flour. Now this is the ratio in which you need these two components to mix, and then you will get 8 number of cookies. Let's suppose one day you want to prepare again the same number of cookies, the same quality, same taste, and when you go to your kitchen you find a problem. The problem is that in your refrigerator you see only there are 2 eggs. Okay, there are only 2 eggs in your refrigerator. There is plenty of flour available, right? Flour is not in less quantity. There's a lot of flour in your kitchen, but you are having only 2 eggs. Now what will you think over here? So definitely you will be thinking, okay, I don't want to compromise on the quality of these cookies, therefore with the 2 number of eggs you will only prepare 4 number of the cookies. So you will think, okay, let's now prepare only the 4 number of cookies. Why? Because you just saw that you are having a limited supply of the eggs. You are not having 4 number of eggs, you are having only 2 eggs. So therefore we can say here that the number of eggs actually here is our limiting reagent. Okay, if you look at in terms of a reaction, in terms of a reactant, you can see that the eggs here becomes our limiting reagent and the flour will be the excess reagent, because excess reagent is the reactant which remains at the end of a reaction, which is available there in plenty. Okay, and this limiting reagent, we can say it limits the number of the cookies, limits the number of the products here, isn't it? So in a chemical reaction, when we do a chemical reaction, one of the reactant which gets consumed first, right, which is present in limited quantity, that will limit the number of the products will be formed, right? So hope you understood this thing. Now let's take another example. Let's take here a chemical reaction. Let's suppose here we react the nitrogen gas with the hydrogen and it forms the ammonia, and this is not a balanced equation. You can see we have 2 nitrogen, so let me just first balance it, and this will be 3 times. Now this is the balanced chemical equation. If you look at this equation, the equation tells us that the reactants, nitrogen and the hydrogen, they combine in 1:3 ratio, which means that if you take 1 mole of a nitrogen, it will react with 3 moles of hydrogen, and at the end of a reaction, you will expect 2 moles of ammonia, right? So you will expect 2 moles of ammonia. So you can see that To get 2 moles of ammonia, you need basically 1 mole of nitrogen and 3 moles of hydrogen. This is as per the balanced chemical equation. Now let's suppose you go to the lab and you are performing an experiment in which you take, let's suppose, rather than 1 mole of a nitrogen, you are taking, let's say, 2 moles of nitrogen. Okay, you take 2 moles of the nitrogen, then what do you expect now? In rather than 1 mole, you are taking here 2 moles of the nitrogen. So obviously you will take how many moles of hydrogen here? You will take, yes, definitely you will take 6 moles, because if you double the nitrogen moles, you will also double the hydrogen moles. So you will take 6 moles of hydrogen. Okay, then what do you expect now? When you react to the 2 moles of nitrogen with the 6 moles of hydrogen, what do you expect? You will definitely expect that you will get again the double the number of the moles of the ammonia. You will get 4 moles of ammonia, right? You will get 4 moles of ammonia. So in this experiment, if you mix, suppose, 2 moles of nitrogen with the 6 moles of the hydrogen, at the end of a reaction, you will only see in the in your reaction mixture just 4 moles of ammonia. This is as per the balanced chemical equation. Right, now let's suppose you are performing again the same experiment, but now you take a different ratio, right? You take a different ratio here. Let's suppose you are taking here the 3 moles of nitrogen, right? So you are actually, as you look at the balanced chemical equation, which says 1:3 is the ratio. So if you triple this, right? If you triple this, that means you are taking 3 moles of hydrogen. What you should expect, how many hydrogen moles you should take here, and you should also triple it, right? 9 moles, right? But let's suppose for example you are taking 12 moles of, or let's suppose you are taking 10 moles rather than 9. You are taking 10 moles. So what does it mean? It means that you are basically taking excess of the hydrogen, isn't it? You need only 9 moles of nitrogen, but you are taking hydrogen, 10 moles. You only need 9 moles. So then what do you think? What will be the amount of a product? Okay, so first of all, you can say here that in this ratio, when you take 3 moles of nitrogen with the 10 moles of hydrogen, you basically need only 9 moles. Out of the 10 moles, you need only 9 moles of the hydrogen. That will actually combine with the 3 moles of nitrogen, and you will have a 1 mole of hydrogen excess at the end of a reaction, isn't it? So I can say here that this nitrogen over here, which is getting consumed first, and it does not remain at the end of a reaction, you will see some product ammonia, and at the end of a reaction you will have some 1 mole of excess hydrogen, isn't it? So out of the 10 moles hydrogen, 9 moles will be consumed, but 1 mole will remain there. So you can say in this case nitrogen is our limiting reagent, isn't it? Nitrogen is our limiting reagent, and hydrogen here will be the excess reagent in this case. Correct? Now what is the amount of product that you will get? We will learn it in just few minutes. The first point here is you need to know how to find the limiting reagent. Okay, how to find the limiting reagent. Let's suppose again I'll do another experiment, and you just think over it. What will be the limiting reagent. Let's suppose if I take 4 moles of nitrogen, and I will take 5 moles of hydrogen, right? The same equation, nitrogen, hydrogen, I'll take it in the 4:5 ratio. 4 moles of nitrogen and 5 moles of hydrogen. So now question here is, which is the limiting reagent? So if you look at the balanced chemical equation says again 1:3. So if you take 1 mole nitrogen, you need 3 moles of hydrogen. But over here you are taking 4 moles of nitrogen, then what do you expect? What you should have the amount of hydrogen? 4 times this now, 4 times 3. 4, that is, yes, that should be the 12 moles, right? You should take 12 moles, but you are taking only 5 moles, right? So that means you have this one in limited quantity. You need actually 12 moles of hydrogen to react with the 4 moles of nitrogen, but you are only taking 5 moles, so that is less, right? You need 12 actually to react with the 4 moles, but you are only having 5 moles. So therefore you can say this is my limiting reagent and this is my excess reagent. Okay, so let's now take another example and let's try to find out how you can actually find the limiting reagent. And you will see we have some questions. You will see the questions will be asked in a little bit different manner, right? Not in this particular in this way. This is a very simple way, right? You can just look at the ratios and you can easily tell which is the limiting reagent and which is the active reagent, right? But let's suppose the question is like this. The question is, if let's suppose the question is, it says if 2 moles of hydrogen combine with let's say the 1 mole of nitrogen to get ammonia. Now find the limiting reagent in this reaction. Okay, so what I will do first thing, the first thing is that I'm gonna write down a balanced chemical equation. Look at the question again. The question is, if 2 moles of hydrogen reacts with 1 mole of a hydrogen, 1 mole of a nitrogen, and they form the ammonia. So what I'll do, I'll just first of all write down the balanced chemical equation. Okay, so the balanced chemical equation is nitrogen and the hydrogen, they combine and they form the ammonia. So what is the ratio here in a balanced chemical equation? We just balanced it. This is 2 times and this is 3 times. So the balanced ratio here is 1:3. Okay, so the first thing that I'll do, I'll just look at the balanced ratio, right? The balanced ratio of the nitrogen and the hydrogen. So I'll write down like this: the nitrogen and the hydrogen. I'll take the ratio of the reactants, right? And what is the ratio? As per the balanced chemical equation, it is 1/3, right? It is 1/3, which means that this is 0.33. So this is the value. This is the ratio as per the balanced chemical equation. As per the balanced chemical equation, the ratio of the nitrogen and hydrogen comes out to be 0.33. Now, what I will do, I will just look at the experimental ratio. In the experiment, in the question says that we are taking how many moles of hydrogen? We are taking 2 moles of hydrogen with 1 mole of nitrogen, right? So this is our experimental ratio. This is our experiment in which we are taking 1 mole of nitrogen and 2 moles of hydrogen. We have to actually check the limiting reagent. We have to find which is the limiting reagent in this case. So again, I will just look at the experimental ratio of the reactant. So what is the ratio? Nitrogen by the hydrogen. What is the ratio here? As per the experiment, as per the question, it is 1/2, which is 0.5, right? So the first thing is finding the ratios in terms of the balanced chemical equation and your the experimental ratio, your question, right? Then you need to check this. You need to compare the experimental ratio with the balanced chemical equation. 3 options are possible, right? 3 things are possible. Either you will have the experimental ratio equal to the balanced ratio. If let's suppose for example, imagine the value does not come 0.5, rather let's suppose the nitrogen hydrogen in the experimental ratio comes out again the same, the 0.33. Then what does it mean? It means that this ratio is exactly similar to the balanced ratio, so which means that there is no limiting reagent. If experimental ratio comes out to be similar to the balanced ratio, right? So it means that there is no limiting reagent in this case, right? In this case, there is no limiting reagent. When the experimental ratio of the reactants is similar to the the balanced ratio. The other thing is, the other 2 options are, it can be the experimental ratio can be less than this balanced ratio, or it can be more than this balanced ratio, right? So this is our reference point here, the balanced ratio. Now in this case, you can see we got here more than 0.33, right? We got a 0.5, which is more than nitrogen, which is more than 0.33, which means that this is only possible when you have nitrogen in excess, right? You can have only this value, more than 0.33, only when you have nitrogen excess, and hydrogen will be, yes, the limiting reagent, correct? So you can say in this case our hydrogen is the limiting reagent. Okay, hydrogen is the limiting reagent because this ratio is less than this ratio is more than the balanced ratio. the numerator here will be the excess reagent. If this ratio is the experimental ratio is more than the balanced ratio, then you can say the numerator here is the excess reagent and the denominator is the limit. The denominator will be the limiting reagent. Now another point here is, after you find the limiting reagent, the next thing that you can get from the limiting reagent is that you can just check what is the amount of a product. How many moles of ammonia you can expect now when you take 1 mole of nitrogen and 3 moles of hydrogen. So since we found that it is the hydrogen which is actually the limiting reagent in this case, correct? Hydrogen is the limiting reagent. Now the second question is, we need to find the amount of a product. So this is our limiting reagent. So now to find to find the amount of a product, you need to relate the limiting reagent with the product, right? So you need to relate these two things. Let's suppose here, I will take here an example of, I'll take the hydrogen out, right? Hydrogen I will relate with what? With the product ammonia, NH3. So if you look at the balanced ratio says that the limiting reagent here is hydrogen and the product here is ammonia. It says that the balanced equation says that basically you need 3 moles of hydrogen to get 2 moles of ammonia, isn't it? 3 moles of hydrogen you need to get 2 moles of ammonia. So therefore 1 mole of hydrogen will produce how many moles of ammonia? Yes, 2 by 3. So 2 by 3 moles of ammonia. So in the experiment you have got how many moles of the limiting reagent? We got 2 moles. So therefore you can say that 2 moles of hydrogen will produce how many moles of ammonia? It is 2 by 3, right? Time is 2. Okay, time is 2. So that means you can say this is 4 by 3. 4 by 3. We can also find the amount of the excess reagent that will consume, right? We can also find out how many moles of nitrogen, which is excess reagent in this case, will be consumed. We have 1 mole of a nitrogen, not all the 1 mole. The 1 mole of nitrogen will not be completely consumed. Some amount of that will remain, unreacted at the end of reaction. So again, if you want to know how many moles of this excess reagent will be consumed, again you're going to relate it with the limiting reagent, right? So you will just relate it with the limiting reagent. So again, I will take these two out. I'll say, okay, hydrogen I will relate with the nitrogen in this case. So I will relate here the hydrogen again with the nitrogen. Hydrogen is my limiting reagent. So as per the balance equation, it says that 3 moles of hydrogen actually reacts with 1 mole of nitrogen here, right? So therefore 1 mole of hydrogen will react with 1 by 3 moles of hydrogen. Okay, 1 by 3 moles of hydrogen, and we have got 2 moles of hydrogen, 2 moles of our excess reagent, isn't it? So therefore 2 moles of excess reagent will react with 2 by 3 moles of the nitrogen. 2 by 3, right? So that means, that 2 by 3 moles of the nitrogen will be consumed. This is the number of the moles of the nitrogen that will be consumed. And therefore, what will be the amount of the nitrogen that will remain unreacted at the end of a reaction? Yes, you can find it by subtracting 1 by 2 by 3. So out of the 1 mole of a nitrogen, right, only 0.66 moles of nitrogen are consumed and 0.33 moles of nitrogen will remain at the end of a reaction. So you can expect that after you react to the 1 mole of a nitrogen with 2 moles of hydrogen, you will expect at the end of a reaction you will have 4 by 3 moles of the the ammonia, which is actually 1.33. You can say 1.333 moles of ammonia. So this is what you expect at the end of a reaction. In the reaction mixture, you will have only these two things at the end of a reaction. One is 1.33 moles of ammonia, and you will have 0.33 moles of nitrogen, which is excess reagent. Okay, so out of 1 mole of a nitrogen, only 0.66 moles were consumed, and 0.33 moles of nitrogen are that will remain in the reaction mixture at the end of a reaction. So hope you got this concept. In the next video, we will do some more questions on the limiting reagent. So thanks for watching the video. Bye for now.